Good morning, my dear children. In the previous class, we studied about electron emission. What is electron emission? Whenever we give energy to a metal, the free electrons that escape from surface. So that is what electron emission. Now there are different types of electron emission. We are going to study what are those types. Look here. First one is thermo-ionic emission. Thermo-ionic emission. Sir, what is this thermo-ionic emission? Look here. Thermo means heat. Thermo means heat. By using heat energy, we are going to take out the electrons from metal surface. Look here. Let me take this is the metal surface. Okay. Now metal has free electrons and they are freely moving inside the volume of metal, but they cannot escape out of the surface by their own. They need external energy. So here in this case we are going to give heat energy. Okay, we are going to give heat energy. Now whenever you give heat energy, what happens inside it? You give heat to some particle, what happens? It starts vibrating. Very simple concept. You give heat to a body, the molecules inside that body will start vibrating. So now we give heat energy. I am writing only free electrons. Okay, these are the free electrons. These free electrons, they will start vibrating here. Okay, they will start vibrating. So they start oscillating because of this heat energy. Their kinetic energy will increase. Nodili ee molecule, okay, sorry, ee free electron idu ee tara vibrate agta adar kinetic energy enagutte jaasti agutte. If we give more and more heat energy, what will happen? Their vibration will increase, their kinetic energy will increase, then the electron will be liberated. Electron will be liberated. Will liberate or leave? Will leave metal surface. Metal surface. Okay. Will leave metal surface. So what is this called? This electron got emitted out of the surface because of heat energy. What do we call heat? Thermo. So look here. Because of the thermal energy given, the electron has been ionized. It has been separated. Okay. So thermo-ionic emission. What is thermo-ionic emission? That is emission of electron. Emission of electron by the application of heat energy. Let's write the definition. Okay. Emission of electrons from metal surface. From metal surface by application of heat energy. Okay. Next type of emission. Okay, field emission. Sir, what is this field emission? Yav field ido? Okay. Football field, cricket field? No, electric field. Look here. We have a metal here, and inside the metal there will be free electrons freely moving inside the volume of metal. Okay, so these are the electrons. All of them are carrying what? Negative charge. Now if we have these two plates, one is positively charged and another one is negatively charged. Okay, so we have positive charge and we have negative charge. In between that there will be electric field. Okay, what is the direction of electric field? Positive to negative. Okay, now look here. Inside the electric field, what happens? The force will be exerted on charge. Now look here. What are the charges? These free electrons are the charges, and this electric field applies force. Am I clear with this? Inside the electric field, force will be exerted on charge, and these all are negative charge, and there will be force acting on it. Look here. This positive charge will attract this electron in this direction. Okay, these positive charges will attract electron. At the same time, these negative charges, okay, these negative charges are going to repel this. That means, pay attention, on this electron, this positive terminals is pulling and this negative charge is pushing. ನೋಡಿ ಇದು ಈ ಪಾಸಿಟಿವ್ ಚಾರ್ಜಸ್ ಇದನ್ನು ಎಳ್ಕೊಳ್ತಾ ಇದೆ, ನೆಗೆಟಿವ್ ಚಾರ್ಜಸ್ ಅಟ್ ದ ಸೇಮ್ ಟೈಮ್ ಅದನ್ನು ಪುಷ್ ಮಾಡ್ತಾ ಇದೆ. ಸೊ ಇಫ್ ವಿ ಕೀಪ್ ಆನ್ ಇನ್ಕ್ರೀಸಿಂಗ್ positive charge here and negative charge here, what will happen? The force and the charge will increase. That means when we increase the potential difference between the plates, strength of the electric field increases and this electric field exerts a force on this electron. ನೋಡಿ ಮಕ್ಕಳ, ಈ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಯಾವಾಗ ಇದನ್ನು ಪುಲ್ ಮಾಡ್ತಾ ಇದೆ, ಈ ನೆಗೆಟಿವ್ ಚಾರ್ಜಸ್ ಇದನ್ನ ಪುಷ್ ಮಾಡ್ತಾ ಇದೆ. ಸೊ when this energy increases, the force on the electron increases, this electron will leave the surface. This electron will leave the surface, or any electron, okay, that will leave the surface of the metal. Okay, this is what electron emission. And why this happened? Because of application of field. If there is no field, no force will act on charge and electron will stay inside the metal. Okay, now this electron has been emitted because of electric field. So what is this field emission? Emission of electron, we will write emission of electron. Try to write on your own. Emission of electron by, okay, emission of electron from metal surface is common. Write it from metal surface. From metal surface by the application of what? Electric field. Application of electric field. Application of electric field. Okay. Next type of emission. What is the next type of emission? Photoelectric emission. Third one, photoelectric emission. Photoelectric emission. Sir, what is this photoelectric emission? This is very simple. Photo means light. Look here. This is the metal surface. This is the metal surface and these are the electrons. They are actually freely moving inside the metal. These are the free electrons. Now, a radiation of suitable frequency. A radiation of suitable frequency. ಇದನ್ನು ಸ್ಟಡಿ ಮಾಡೋಣ ಮಕ್ಕಳ. ಓಕೆ, ಬೇಸಿಕಲಿ ಒಂದು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ಫ್ರೀಕ್ವೆನ್ಸಿ ಅಂದರೆ ಏನಂತ. ಸಿ ಆಲ್ ದೀಸ್ ರೇಡಿಯೇಷನ್ಸ್, ಓಕೆ, light, UV rays and all these, light, UV rays, X-rays, gamma rays, all of these are radiations, and these radiations they travel with photons. Okay, these radiations are made up of photons and these photons are small packets of energy. Am I clear with this? If the energy carried by the photon is more, then the frequency of that radiation will be more. Am I clear with this? So frequency is always associated with the amount of energy carried by photon of a radiation. Okay, now the radiation of suitable frequency falls on it and the electron is emitted. So generally what we have taken here is, we have here taken as light as the radiation. Okay, so light falls on it. Light falls on the metallic surface and the electrons will be emitted from the metallic surface. That we call it as photoelectric emission. Photo means light. Because of the energy carried by the light, an electron has been emitted by surface. So that is what photoelectric emission. So we will write the definition. What is that? Emission of electrons by application of light. We can also define in this manner: emission of electrons when light falls on metal surface. Okay, now see, generally for the visible light there will be emission only in alkali metals. Okay, those are the basic type of metals. In that, these free electrons are not strongly bound to the nucleus. Because of it, there will be emission whenever the light falls on it. So for an example, we can take potassium, calcium. For calcium, if you take calcium, light falls on it and the electrons will be emitted. Okay, so next type of emission. Okay, where can I write? I will erase this diagrams. Next type of emission is secondary emission. Okay, secondary emission. What is this secondary emission? This is a very simple thing. Free electrons cannot get out of the surface on their own, they need extra energy. Okay, so for that, look here. There is a metal surface, okay, and these are the free electrons. These are the free electrons. They are actually moving freely inside the volume of conductor. Now what happens when an high speed electron this high speed electron will come here and that will collide on the surface. Okay, so now there is an electron which is about to be emitted out of the surface. When this electron comes and bombards with this metal surface, this electron, when it is moving, it has got kinetic energy, and this kinetic energy will be transferred to this electron, and now this electron will be ejected out. So this is emitted electron. So why this happened? Because of the bombardment by high speed electron. So what is secondary emission? Emission of electron by bombarding high speed electrons. We will write it. Emission of electrons from metal surface by bombarding high speed electrons. These are the 4 types of electron emission. See, look here. What is the first one? First one is thermoionic emission, where we heat the metal surface. Because of the vibration, electron will leave the surface. That is thermoionic. And field emission, we are going to keep the metal inside of electric field, and we are going to increase the strength of electric field. Because of that, electron will jump out of the surface. And third one is photoelectric. As the name indicates, photo means light, electron emission. So whenever the light falls on the metal body, metallic surface, if the electron is emitted, that is because of photoelectric emission. Okay, that's one. Last one is secondary emission. Emission of electrons from the metal surface takes place because of bombarding, because we bombard the surface with high speed electrons. Thank you. Now we are going to study photoelectric emission. Look here, we will take a metal surface. Okay, this is the metal surface, and we have got free electrons in the volume of conductor, which are actually moving inside the volume, and they get kinetic energy because of the collision and other factors, and they cannot leave the surface. Now if we make a radiation of suitable frequency fall on the metal surface, radiation of suitable frequency, okay, radiation of suitable frequency. So when the radiation, maybe light, UV rays, X-rays, or any radiation, when the radiation with a suitable frequency is here indicating how much energy is carried by a photon of that radiation, particular radiation. A radiation ಬರ್ತಿದೆಯಲ್ಲ ಅದರ ಎಷ್ಟು ಎನರ್ಜಿ ಇದೆ ಅಂತ ಡಿಸೈಡ್ ಮಾಡಿ. Okay, when the radiation falls on the metal surface, these electron which are about to jump out of the metal surface, they get energy. Because of the energy given by the radiation, there will be emitted from the metal surface. They will be emitted from metal surface. Emission of electrons. Okay, emission of electrons. So that we call it as photoelectric effect. Photoelectric effect or photoelectric emission. Okay. Now look here. We will write the definition. Emission of electron. Why it happened? Because radiation of suitable frequency fell on the metal surface. We will write the definition. Okay. So let us write the definition. Emission of electrons from metal surface when radiation of suitable frequency falls on metal surface. Metal surface is photoelectric. So we have a metal surface here and there will be free electrons here. And these are the free electrons which are vibrating inside the volume of metal. Now, for understanding purpose of this suitable frequency, I will take visible light. Okay, and visible light consists of a spectrum of colors. Okay, VIBGYOR, violet, indigo, blue, green, yellow, orange, red. Okay, in this direction, wavelength is increasing. In this direction, frequency is increasing. Always remember, kids, frequency is associated with the energy carried by the radiation, and this is the wavelength, that is the length of wave. Okay, look here, red has a large wavelength but less frequency. Orange has got wavelength which is lesser than red but the frequency higher than red. Andre highest frequency yadukide illi? Sir, violet, then indigo, then blue, then green, then yellow, then orange, then red. Am I clear with this? Now, if the frequency changes, color of the light will also change. Now, for this metal, I will make red light fall on the surface. Red light irradiates the surface, but there is no electron emission. Okay, red light failed. No, it could not make an electron ejection. Okay. Now we will make orange fall on the surface. Orange light fall on the surface. Still, there is no emission of electrons. Now, with the orange, we could not make electron leave the surface. Now, when we apply yellow color, okay, is there any emission? Okay, we have applied yellow and electron has been emitted from the surface. Emitted electron. So now there is an electron emission. Only when we make yellow light falls on this metal. That means with orange and red light we could not make emission. Now, which is the suitable frequency? Frequency of yellow light is the suitable frequency for the emission here. Am I clear with this? Okay, sir, if we make green light fall on the surface, is there an emission? Definitely you are going to have emission. Why? Because it has more frequency than yellow. So for blue it will happen because it is more than yellow. Below yellow, orange and red, for those frequency there won't be emission. So this is about frequency, suitable frequency. Okay, next we are going to define threshold frequency. For this example will help you. Okay, threshold frequency. Okay, now look here, we are going to define it in very easy manner. Look here children, for red light, is there an emission? No sir. For that frequency, no emission. For orange light, is there any emission? No sir. Which is the minimum frequency? Frequency of yellow light, responsible for emission of electron, and this is called as what? Threshold frequency. What is threshold frequency? The minimum frequency of radiation. The minimum frequency of radiation which will cause electrons to emitted out of the surface. Am I clear with this? What is this? Threshold frequency. Minimum. Threshold frequency is minimum frequency of radiation, minimum frequency of radiation, that is what we called as suitable frequency. Not suitable, minimum frequency is more than enough. Okay, so minimum frequency of radiation for which electrons will be emitted from metal surface. Now, sir, for the example that you have given, can I call green a threshold frequency? No. Green light's frequency is more than yellow light's frequency. That means, which is the minimum frequency required? Yellow light in frequency idre electron emit agutte. Green light adkin jaasti ide, emission antu agutte. But can we call that as a threshold frequency? No, we can't call it as a threshold frequency. Okay, this is metal 1. There is another metal which is metal 2, and it has also got free electron. Now we will irradiate this with the radiation. Okay, red hakadvi, emit aglilla. Orange light biಟ್ವಿ, electron emit ಆಗಲಿಲ್ಲ. Yellow ಹಾಕಿದ್ವಿ, orange light emit ಆಗಲಿಲ್ಲ. Green light ಹಾಕಿದ್ವಿ, emit ಆಗಲಿಲ್ಲ. Blue light ಹಾಕಿದ್ವಿ. Okay, blue light ಹಾಕಿದಾಗ ಏನಾಯಿತು? emit ಆಯಿತು. ಸೊ ಹಾಗಾದರೆ ಈ ಮೆಟಲ್ಗೆ threshold frequency ಯಾವುದು? The frequency of blue light. Now for different metals threshold frequency is different. Can I write that line? Okay, we'll mention it. For different metals threshold frequency is different. Always remember, kids, threshold means minimum. What is that? Threshold frequency is different for different metals. Threshold frequency is different. Okay, that's good. Now, different metals will have different threshold frequency. What is threshold frequency? The minimum frequency of radiation for which electrons will be emitted out of the surface of the metal. Okay. Next, see there are. Can I erase this? I will erase these examples, children. Okay. I want to give two important points to be noted. So there is alkali metals. These are the basic metals like potassium, calcium, sodium. Okay. The photoelectric effect is observed when the visible light falls on it. Photoelectric effect is observed when visible light falls on them. See, what is the meaning of it? Normal visible light ಮಕ್ಕಳ ಇದ್ರ ಮೇಲೆ ಬಿದ್ದರೆ, ಅದ್ರ ಮೇಲೆ ಪೊಟ್ಯಾಷಿಯಂ, ಕ್ಯಾಲ್ಸಿಯಂ, ಸೋಡಿಯಂ ಅಂತ ಆಲ್ಕಲಿ ಮೆಟಲ್ ಮೇಲೆ ಬಿದ್ದರೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಈಸಿಯಾಗಿ ಎಮಿಟ್ ಆಗ್ತಾರೆ. ಬಟ್ ಫಾರ್ ಸಮ್ ಮೆಟಲ್ಸ್ ಲೈಕ್ ಜಿಂಕ್, okay, for metal like zinc, photoelectric photoelectric effect is observed when UV rays falls on it. So this is about photoelectric emission. See, what is photoelectric effect? That is a phenomenon of emission of electrons from the metal surface when the suitable radiation of suitable frequency falls on it. That is a very important thing. And another one is threshold frequency. What is threshold frequency? Minimum frequency. That is responsible for electron emission from the metal surface. For different metals, threshold frequency is different. And then alkali metals like potassium, calcium, sodium, we can observe photoelectric effect with visible light. That means in these metals, what happens, the electrons are very freely bonded to nucleus. They will just jump out when the light falls on it. And for the metal like zinc, so we need UV rays to observe photoelectric effect. And this photoelectric effect generally observed in all these substances, but generally and easily observed in case of metals. Okay, thank you. Children, scientist Philip Lennard made a wonderful experiment to show photoelectric effect. His experiment made us realize what photoelectric effect is actually in reality. Okay, for that he used this setup. In this setup we have, look here, this is cathode. Okay, we'll take this as cathode. Okay, this is photosensitive cathode. What is this cathode and anode? These are electrodes. Okay, so we can make it negative or positive. Here we can make it negative or positive. Okay, so now, and this is the evacuated glass tube. So what is evacuated glass tube? Evacuated glass tube means inside it we do not leave any material. We take every material out of it. Okay, so generally we can create vacuum here. Generally at that time he didn't create vacuum. There was an air in the tube. Except air, no material was present inside the tube. Okay, now this is commuter. What is the use of commuter, sir? See, this commuter system is used to change positive or negative terminal given to the anode. So this is anode. This terminal is anode. This electrode. We charge it generally positive or negative with respect to cathode. Look here. This wire is anode's wire. This is anode's wire. This wire, look here, this wire is cathode's wire. Look here, if we connect here, look here, this is the positive terminal, this is the negative terminal. If we connect this terminal, this side, okay, this is positive and this is negative. If we connect this side, this terminal to this terminal, what happens? Cathode becomes positive. If we connect this terminal with this terminal, what happens? Cathode becomes negatively charged. Once again, look here, this is a positive terminal, this is negative terminal, and this is positive means this side, this is positive, and here this is negative. Am I clear with this? Negative. We can connect here and here. If we connect these two terminals, these two ends to anode and cathode, anode becomes positive and cathode becomes negative. Now, instead of this connection, we will connect here. What will happen? Cathode will become positive, anode will become negative. How we are doing? By the help of commutator. So, commutator na use madidre makla cathode matte anode na ಚಾರ್ಜ್ ಕಂಡೀಷನ್ಸ್ ನಾವು ಚೇಂಜ್ ಮಾಡ್ಬೋದು. ಟರ್ಮಿನಲ್ಸ್ನ ಚೇಂಜ್ ಮಾಡ್ಬೋದು. ಪಾಸಿಟಿವ್ ಟರ್ಮಿನಲ್ ಮಾಡ್ಬೋದು ಅಥವಾ ನೆಗೆಟಿವ್ ಟರ್ಮಿನಲ್ ಮಾಡ್ಬೋದು. ಈ ಕಡೆಯಿಂದ ಕೂಡ ನೆಗೆಟಿವ್ ಮಾಡ್ಬೋದು ಅಥವಾ ಪಾಸಿಟಿವ್ ಮಾಡ್ಬೋದು. ಹೇಗೆ ಮಾಡಿದ್ವಿ? ಕಮ್ಯೂಟರ್ಸ್. ಆ್ಯಂಡ್ ನಾವು ದಿಸ್ ಈಸ್ ರಿಯೋಸ್ಟಾಟ್. Sir, what is this rheostat? See, in the rheostat we can vary resistivity. resistance. We can vary resistance. By varying resistance, we can change the potential difference. Am I clear with this? Now, this is the voltmeter which gives us what is the potential difference across anode and cathode. And this is an ammeter which is used to study the photoelectric current. Now, look at this. This is the evacuated glass tube, and this is cathode, and this is anode, okay? And this is the commutator. With the help of commutator, we can change we can make anode positive or negative with respect to cathode. Then we have a voltmeter connected across here, and which will give us potential difference across anode and cathode. And this ammeter is connected to calculate how much current is flowing in the circuit. And this is a rheostat. Why do we use rheostat? With the use of rheostat, we can change resistance. With the help, we can change potential difference. Okay, this is the battery, and this is positive terminal, and this is negative terminal. This is higher potential, this is lower potential. Now, this is window, okay? Quartz window. Quartz window, through which radiation will fall on the emitter plate. So this is the source of radiation. This is the source of radiation. Now, look here. In the Lennard's experiment, what he did is, he made radiation of suitable frequency fall on this cathode tube. Cathode plate. This cathode plate is sensitive and it is an emitter plate. Whenever the UV radiation, generally used UV radiation, whenever the radiation falls here, there are electrons emitted. These electrons are emitted. And these electrons are negative in nature and attracted by anode. Nodi bakla, UV radiation emitter plate ಮೇಲೆ ಬಿದ್ದ ತಕ್ಷಣ ಏನಾಗಿದೆ, electrons emit ಆಯಿತು, and these electrons are attracted by anode. So now when the UV rays falls, electrons are emitted, electrons are attracted by the anode. So positive anode ಏನು ಮಾಡ್ತು, electrons na attract ಮಾಡ್ತು. These electrons will flow as current in the circuit, that will be indicated in ammeter. Okay, so now when UV radiation is stopped, the current also stopped. So this indicated that whenever the radiation of suitable frequency falls on the emitter plate, there will be electrons emitted, and these electrons emitted are attracted by anode, and that constitutes a current which is read by ammeter. Am I clear with this? So I am going to write that. Okay. Children, we have written all the observations that has been done during Lennard's experiment. So what happened in the Lennard's experiment? So there is a source of radiation. From that radiation, UV rays, okay? UV rays will fall on the emitter photosensitive cathode. So ಇಲ್ಲಿಗೆ UV rays ಬಿದ್ದಾಗ ಏನಾಯಿತು, ಇದರಿಂದ electrons emit ಆಯಿತು. electrons emit ಆಗಿದ್ದು ಏನಾಯಿತು, ಪಾಸಿಟಿವ್ ಆನೋಡಿಂದ ಅಟ್ರಾಕ್ಟ್ ಆಗಿದೆ. ಆ ನೋಡಿ ಇಲ್ಲಿ ಅಟ್ರಾಕ್ಟ್ ಆದಾಗ ಏನಾಗುತ್ತೆ, ಸೊ there is an extra electrons that constitutes to current, and that current is read by the ammeter. Okay, so now pay attention. So that is written here. When the UV radiation are allowed to fall on the emitter plate, there is an what? Current flow in the circuit. So whenever there is an UV radiation, there is a current flow in circuit. Now when we stop UV radiation, that means if we stop the UV radiation, there is no electric current in the circuit. So which implies whenever UV radiation falls on the surface, what happens? Electrons are emitted from emitter plates, that is cathode, and attracted by positive anode, and there is a current. If we stop it, no current. Am I clear with this? Okay, so this experiment showed photoelectric effect, evidence of photoelectric effect. Thank you. My dear students, Lennard conducted experiments. It showed the existence of photoelectric effect. At the same time, during 1888, a German scientist named Ludwig Franz Wilhelm Hallwachs conducted an experiment whose observation is generally known as Hallwachs observation. In this Hallwachs observation, what he did is, he took an electroscope. We all know what is electroscope. We have studied electroscope in gold leaf electroscope experiment. Okay, so yenagutte, so when we connect a charged body, when we connect charged body, look here, this is the conductor, this is the conductor, this is the glass case, and these two are the leaves. When we connect a charged body, charges will flow from this body to these leaves. Both of the leaves becomes charged with the same kind of charge, then they will repel each other and there will be deflection. So ಈ ಲೀವ್ಸ್ ದೂರ ಅವ್ರ ಅರ್ಥ ಏನು, ಚಾರ್ಜ್ ಇದೆ ಅಂತ, ಹತ್ರ ಬಂದ ಅರ್ಥ ಏನು, ಚಾರ್ಜಸ್ ಕಮ್ಮಿ ಆಯಿತು ಅಂತ. ಅಕಸ್ಮಾತ್ ನಾವು ಯಾವುದೋ ಈ ಬಾಡಿನ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ವಿ, ಲೀವ್ಸ್ ಹೇಗಿದೆ ಹಾಗೆ ಇದೆ, ಚೇಂಜ್ ಆಗಿಲ್ಲ, ಮೀನಿಂಗ್ ಏನು ಸರ್, ದೆರ್ ಇಸ್ ನೋ ಚಾರ್ಜ್ ಆನ್ ದ ಬಾಡಿ. ಓಕೆ, ಸೊ ವಾಟ್ ಹಿ ಡಿಡ್ ಈಸ್ he connected a zinc plate. This is a zinc plate. See, in the first experiment what he did is, let me write it here. Okay, we will write three cases. This is the conducting rod, this is zinc, this is zinc. Let me take zinc as uncharged zinc plate is connected to the electroscope. This is the electroscope. Now it is uncharged and he irradiated this plate with UV radiation, UV rays na ಈ zinc plate ಮೇಲೆ ಹಾಕ್ದಾಗ ಏನಾಯಿತು, now there is an deflection here. Initially it was like this. There is a zinc plate which is uncharged. Uncharged means there is no charge on it. Okay, so when the UV rays falls on the plate, what happens? The deflection increased. Why there is a deflection? There should be charge flown to the leaves. ಹೌದಲ್ವಾ, ಇಲ್ಲಿಂದ ಅಕಸ್ಮಾತ್ ಚಾರ್ಜಸ್ ಬಂದು ಈ ಲೀವ್ಸಲ್ಲಿ ಚಾರ್ಜ್ ಬಂದು ಅಕಾಮಿಡೇಟ್ ಆದರೆ ಏನಾಗುತ್ತೆ, ಎರಡೂ ಕೂಡ ಸೇಮ್ ಚಾರ್ಜಿಂದ ಅಕಾಮಿಡೇಟ್ ಆಗೋದ್ರಿಂದ ದೇ ವಿಲ್ ರಿಪೆಲ್. ಸೊ ನಾವು ದೇರ್ ಇಸ್ ಎ ರಿಪಲ್ಷನ್. ವಿ ಕ್ಯಾನ್ಸಲ್ UV rays, ನೋ ಎಫೆಕ್ಟ್ ಇಸ್ ಅಬ್ಸರ್ವ್ಡ್. UV rays ಇಲ್ಲಿದ್ದಾಗ zinc plate ಕನೆಕ್ಟ್ ಮಾಡಿದ್ದೀವಿ, ಅನ್ಚಾರ್ಜ್, ಎಸ್ ಅನ್ಚಾರ್ಜ್, ಬಟ್ ವೆನ್ ಎವರ್ ದೇರ್ ಈಸ್ ಎನ್ UV rays, what happens? There is a deflection. That shows whenever UV radiation falls on the zinc, the negative charges from the zinc are emitted and those charges comes, and here in the next experiment what he did, he connected zinc which is positively charged plate, zinc plate, to an electroscope. Now after that he did this UV rays fall on the zinc plate. Okay, he made UV rays fall on the zinc plate. Now what happened? The positive charge on the plates increased. That means positive charge plate ಮೇಲೆ increase ಆಗಬೇಕಂದ್ರೆ, so ನಾವೇನು ಮಾಡಬೇಕು, ನೆಗೆಟಿವ್ ಚಾರ್ಜಸ್ ಶುಡ್ ಬಿ ಟೇಕನ್ ಔಟ್ ಆಫ್ ದ ಬಾಡಿ. ಇಫ್ ಇಟ್ ಈಸ್ ಬಿಕಮಿಂಗ್ ಮೋರ್ ಪಾಸಿಟಿವ್ಲಿ ಚಾರ್ಜ್ಡ್, ದಟ್ ಮೀನ್ಸ್ more electrons are ejected, and that showed as a deflection between the leaves. So understand the concept. Look here, he connected positively charged zinc plate to an electroscope and he made UV rays fall on that. The positive charges increased on the zinc plate. See, if the positive charge is increasing on the body, that means we are removing electrons. That means electron has been removed from the body and that electron flowed here and showed the deflection. This is his second observation. Students, these are the observation of Hallwachs experiment. First, what is that? Uncharged zinc plate connected to an electroscope became positively charged when it is irradiated by UV rays. Zinc plate ಮೇಲೆ UV rays ಬಿದ್ದಾಗ ಏನಾಗುತ್ತೆ, the plate becomes positively charged. ಯಾಕೆ? ನೆಗೆಟಿವ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದರಿಂದ ಎಮಿಟ್ ಆಗಿದ್ದೇನಾಯಿತು, ಇಲ್ಲಿ ಲೀವ್ಸಲ್ಲಿ ಬಂದು ಡಿಫ್ಲೆಕ್ಷನ್ ತೋರಿಸ್ತು. ಓಕೆ, ನೆಕ್ಸ್ಟ್ positively charged plate. When you connect a positively charged plate here and irradiate it with UV rays, ಇದು ಪಾಸಿಟಿವ್ಲಿ ಚಾರ್ಜಡ್ ಪ್ಲೇಟ್ ಆಗಿದ್ದಾಗ ಅದಕ್ಕೆ ಮತ್ತೆ ನಾವು UV rays ಬಿಟ್ಟಾಗ ಏನಾಗುತ್ತೆ, ಆ UV rays ಬಿಟ್ಟಿದ್ರಿಂದ ನೆಗೆಟಿವ್ ಚಾರ್ಜಸ್ ಅದರಿಂದ ಎಲಿಮಿನೇಟ್ ಆಗಿ ಬಂದು ಇಲ್ಲಿ ಡಿಫ್ಲೆಕ್ಷನ್ ತೋರಿಸುತ್ತೆ. ಜಿಂಕ್ ಪ್ಲೇಟ್ ಬಿಕಮ್ಸ್ ಮೋರ್ ಪಾಸಿಟಿವ್. So that is written here. Positively charged plate becomes more positively charged when it is irradiated by UV rays. What is the conclusion? So conclusion is this: negative charges are eliminated from zinc plate when it is irradiated by UV rays. That's all about Lennard's and Hallwachs experiment.